Hello, I am Seema and welcome to part 4 of the chapter Hydrocarbons. We discussed isomerism in alkanes in the previous video. Moving ahead with our discussion of alkanes, let us now just revise how we do the nomenclature of alkanes. But before we come to naming of these hydrocarbons, let us first talk of the 4 types of carbons that can exist. We know carbon has a valency of 4. It can form 4 bonds. So based on the number of bonds carbon is forming with other carbon atoms, we classify them in these 4 categories. As the name suggests, if the carbon is attached to only one other carbon or no other carbon, as in the case of methane, if it is attached to only one other carbon atom, it is known as a primary carbon atom. If the carbon atom is attached to 2 other carbon atoms, then it is known as a 2-degree or a secondary carbon atom. If it is joined to, it forms bonds with 3 different carbon atoms, then it is a tertiary carbon or a 3-degree carbon. And if it is forming, the carbon is forming bonds with 4 different carbon atoms, then it is a quaternary carbon atom. So based on the number of carbon atoms that particular carbon is attached to, you can allot it whether it is a primary carbon, a secondary carbon, tertiary or quaternary. So this example is one where you can see all kinds of carbons. Take a look at each carbon and let us assign which kind of carbon is it. This is the first carbon. This carbon is attached to only one other carbon. So which kind of carbon would it be? It would be a primary carbon. So I would write it is 1 degree. How about the second carbon now? This carbon is attached to 2 other carbon atoms. So it is a secondary carbon. This carbon is attached to 1, 2, 3 carbons. Therefore this carbon is a tertiary carbon. This carbon is attached to only one carbon. Therefore this carbon is primary. Similarly, this carbon is attached to only one carbon, so this carbon is primary. How about this carbon now? This carbon is attached to 1, 2, 3, 4 carbons. So this carbon is quaternary, 4 degree. This carbon is attached to only one carbon, so it is primary. And this carbon is also attached to only one other carbon, therefore this is also primary. So you can assign the primary, secondary, tertiary and quaternary carbons by looking at the number of bonds that particular carbon is forming with other carbons. Now why is it important? Why am I talking of this before I go to nomenclature? Because in nomenclature sometimes we do use these prefixes, that is whether the carbon is secondary. If it is secondary, for primary there is no need to write a prefix. But if it is secondary or tertiary, sometimes we use the prefixes like sec for secondary and tert for tertiary. So when we do use those prefixes, in that case we should know what that prefix means, and that is when we would be using the prefix in a name. So what would be the name of this compound? In order to name a hydrocarbon, you know, the first step is to find out the longest chain. The longest chain here is this straight chain and it has got 3 branches. Okay, the longest chain is the straight chain with 3 branches. So this is carbon 1, carbon 2, carbon 3, 4, 5. This is one branch, this is one branch, you'll say this is one branch, this is one branch, and this is one branch, right? It has 3 branches. So what are the branches and what is the group in each of the branches? This is a methyl group, this is a methyl group, this is a methyl group. So you have 3 methyl groups. When you have 3 methyl groups, you can call it trimethyl. Then we have to give the locants. Now I'm not going to explain each step to you because I assume that you know nomenclature. So I would request you to watch the previous chapter nicely, understand nomenclature, so that then it becomes easier for us to really name these compounds. So the next step would be to find out the locants, that is, and according to the lowest sum of locants rules, the sum of all the locants that you get should be a minimum number. So this is the chain. It has got 3 substituents. If I count from this side, the locants I get for the substituents are this one is at the second carbon, this is at the second carbon if I'm counting from this side, and this is on the third carbon. So the locants I get are 2, 2 and 3. If I count from this direction, I will get the first locant, this is 3, and these two methyl groups would be on the fourth carbon, so I would call them 3, 4, 4. 3, 4, 4. The three methyl groups can be either at 2, 2, 3 if I count from this direction, or if I count from that direction, the locants would be 3, 4, 4. Which ones are smaller? 2, 2, 3 is, the sum of this would be smaller. So you will always choose the locants which give you the smaller sum, lowest sum of locants. You will choose that name where the sum of the locants is the lowest. So lowest sum of locants, according to that rule, this compound would be called 2,2,3 trimethyl pentane, right? And not 3,4,4. And why tri? Because all the substituents, they are all methyl groups. So it will be 2,2,3 trimethyl pentane. The root hydrocarbon was pentane. So let us now name some of these compounds and revise our rules of nomenclature. This is the first compound. It has got how many carbons? 1, 2, 3, 4, 5, 6. The longest chain has 6 carbons. Look here, I could have counted 1, 2, 3, 4, 5, 6. Even in that case, then this carbon would have had an ethyl group on this side. And if I count it this way, then this carbon has an ethyl group on that side. It's always easier to keep the compound straight. It means that if this was a propyl group, let us say, then my chain would have turned this way. Right? Let us assume that this was a propyl group. Instead of CH3, this was CH2, CH3. Then my longest chain would have been 1, 2, 3, 4, 5, 6, 7. So the chain would have turned like this, and the 1, 2, 3, 4, 5, 6, this would not be my parent hydrocarbon or the skeleton. But in this case, in this example that we have in the textbook, it is 1, 2, 3, 4, 5, 6. So it is hexane. So the first thing you do is you write the word root. The word root for the parent chain is hex. Alright, it is HEX, and since it is saturated, it is hexane. Right? That is the thing that you write, that you find out first. Then, what are the groups that you have? The substituents. You have two substituents here. What are the two substituents? You have an ethyl group here, and you have a methyl group here. Okay, so you have two substituents. One is an ethyl group, the second is a methyl group. And let us now allot locants. If I count from this direction, the first carbon that has the substituent is the third carbon, right? 1, 2, 3. This would be 3, 4, 5. So the locants would be 3, 5. And if I count from this direction, I get 1, 2, 3, 4, 5, 6. So second carbon and fourth carbon. So second and fourth, which will have the lower sum. 5 plus 3 is 8. 4 plus 2 is 6. So the lower locants are in this direction. So I will count from this direction. When I count from this direction, I get lower locants. Okay. So obviously I will be using these locants, 2 and 4. Now the question is, I have to name methyl and ethyl. How will I decide which one I write first? Do I write methyl first because it is on the second carbon and ethyl second because it is on the fourth carbon? No. When you are naming them, you may allot the locants according to the lowest sum of locants. But when you are naming them, you will write that substituent first, which is lower in alphabetical order. That is, ethyl starts with E and methyl starts with M. Which comes first in the alphabetical order? E comes before M. So you have to write ethyl first and methyl later. So if I have to write ethyl first, what is the locant for ethyl? For ethyl, ethyl is on the fourth carbon. So I'll write 4 hyphen ethyl. The name always starts with a capital letter. 4 ethyl. Then you write 2 methyl hexane. There should be no gap between the methyl and the hexane. So it is 4 ethyl 2 methyl hexane. That is the name of your hydrocarbon. Is it clear? So how we did it? What were the rules that we followed here? The lowest sum of locants rule. We chose the locants which had the lowest sum. This is the rule that you follow in every name that you give. If there are substituents, you have to take care of the lowest sum of locants. Actually, you have to follow all the rules, but this is the first rule that you would take care of. Then would be the which substituent will you write first or later would depend on the alphabetical order, right? So now let us do this second compound. Now the second compound, let us again find the longest chain here. If you look at this chain, which appears to be the longest, you'll count 1, 2, 3, 4, 5, 6, 7, 8. Okay? If I count 1, 2, 3, 4, 5, 6, 7, 8, this is also 8. 1, 2, 3, 4, 5, 6, 7, 8, this is also 8. So even if I make my chain try to count in a more crooked fashion, I will still get the same number. So why should I really make it complicated for myself? I will choose this to be the longest chain. Let me try this also. 1, 2, 3, 4, 5, 6, 7. This is 7 and I got 8 carbons on this. So obviously this is the longest chain. Actually these 3 are longest chains, but I will choose this one. Even if I chose one of these, it actually means the same thing, this carbon is branching into 3 ethyl groups if you really look at it. So one of the ethyl groups you will choose as the one that belongs to the chain, the other 2 will form branches. So you'll choose this to be your first, the root. So the word root you will get from here. What is the word root? 1, 2, 3, 4, 5, 6, 7, 8. 8 means it is oct. It will be an octane. So I will be ending my name with octane. That is clear. Let us now come to the substituents. So when I have to see the substituents, what are the substituents I have? I have one substituent here. I have one substituent here. What is a substituent? Anything that is bound to the carbons of the chain. The whole thing will be a substituent, right? This is the stem of the tree or the trunk of the tree. And all the others which are coming out from the trunk of the tree are branches. The branch may have leaves, it may have flowers, it may have fruit, but that is still one branch. So however big it may be, that one attachment that it has to the main trunk of the tree, that whole thing will be one branch. So you have one branch here, one branch here, one branch is here, and this is one branch. Do you see this? Oh. This whole thing is one branch, right? So do you see how many branches this compound has? It has 4 branches. All right, that is also done, that it has got 4 branches. Now the next step would be to find out the lowest sum of locants. Before I name the branches or see the groups that are present, I have to see what is the direction from which I will be naming this compound. I have to choose one direction. In the beginning itself, I have to assign the locants, that these are the locants that I will be giving to the compound. If you really look, this carbon has 2 groups attached to it, or 2 substituents attached to it. Therefore, this number where it has 2, whatever number it gets, the lowest number, these 2 you should try to get a lower number for all the locants. So if I count from this direction, 1, 2, 3. On the 3rd carbon there are 2 substituents. So the 2 locants will be 3 and 3. This is the 4th carbon, so it will be 4, and this is the 5th carbon, so it will be 5. If I count from this side, 1, 2, 3, 4, the first locant I get is 4, which is higher than this. This itself gives you an idea, But still, why do we find out all the locants? Because ultimately, the sum of all of these should be lower. And usually, when you start from the side where you get a lower number, for one of the substituents, that usually gives away that this is going to be the side from which you will be counting. Yet you will always find out the sum of all the locants. So this is 4, this is 5, and this is 6 and 6. 4, 5, 6, 6, 3, 3, 4, 5, which is smaller? Obviously this one. So I will choose the locants to be 3, 3, 4, 5. This is 3, this is 3, this is 4, and this is 5. On third position, I have 2 ethyl groups. Now, when I'm naming them, I have to take care of the alphabetical order also. So when I'm naming them, I have 2 ethyl groups, E, the alphabet is E. I have 1 methyl group, the alphabet is M. Okay? And look at this. This is a propyl group. It's a propyl group, but the propyl group you would assume would attach itself on the first carbon. If it was a propyl group, you would expect it to be CH2, CH2, CH3. Then the first carbon is attaching itself to the to the carbon of the parent chain. But in this case, we find that this propyl group, in this propyl group, it is the second carbon which is attached to the parent chain. So the propyl group can be named in different ways now because of this. One way is to call it it is an isopropyl group, right? Because why is it iso? Because you call such compounds where the carbon which is attached is attached to 2 other carbons, you call it an iso compound. So this is an isopropyl group. You can also call it a secondary propyl group. Right? It can be called because it is 2 degree. It is the second carbon which is attached. This carbon is attached to, this carbon is attached to 2 other, if we are only looking at the group, it is attached to 2 other carbons. So it is a secondary propyl group. So either you will call it a secondary propyl group, or you will call it an isopropyl group, or you can call it a if you assume, if you go strictly by IUPAC nomenclature, because both secondary and iso are common names. So now, if I have to name this by the IUPAC nomenclature, then I will take one of these as the parent chain, and I will take one of the methyl groups as a branch. That is, let us say these are 2 carbons. So I will call it an ethyl group, but the ethyl group has a methyl group substituted to it. So I will say, I'll count this as the first carbon. So I'll call it 1 methyl ethyl. And I'll put it in a bracket. This would be my substituent group here. It will be 1 methyl ethyl. So I can now name this compound according to this. If I have to now write down the name, how would I do it? I will end it in octane. I know that, because it had 8 carbon atoms, and octane is my parent hydrocarbon. The 4 substituents that I have are ethyl, ethyl, E, M are the alphabets. So which will come? Ethyl will come first, methyl will come later, I know. But what about this? Isopropyl. If I use isopropyl as my if I use isopropyl as my name of the substituent, then I will choose I in alphabetical order. If I use secondary is written as this is one secondary propyl. You can either write isopropyl or secondary propyl or 1 methyl ethyl. If you write isopropyl, I will be the alphabet that you will choose. If you're writing secondary propyl, there is a hyphen. Secondary is not, you do not take the S of the secondary in the alphabetical order, you take the P of the propyl in the alphabetical order. I hope I'm clear. When you're writing isopropyl, we don't take P as the alphabetical order, we take I as the alphabetical order, because isopropyl becomes one word. But when we write secondary propyl, the secondary is only written separately to tell you what kind of carbon it is. It is not actually the name of the substituent. Therefore, when you're choosing the alphabetical order, you will choose P as the alphabetical order. You will not choose S. So if you are using the name secondary propyl for this group, then you will choose P in alphabetical order. Okay, either P Or if you're using one methyl ethyl, it is M, you will choose M, and M will clash here. Do you see this? You have one methyl here, one methyl here. So that may clash here. And the third one that you could choose is isopropyl. Normally when you have such, so many choices, you can name the compound using any of the choices. But it is common practice that iso is very easily understood. Iso means it is the second carbon. So in IUPAC nomenclature, it is a practice that we sometimes use the iso, that is the common name or the common prefix, which is iso. Even the secondary is common, you can use that also. But in that case, the alphabetical order, when you're choosing the alphabetical order, it will be the alphabet of the alkyl group which will be chosen. But in iso, it will be I which will decide the alphabetical order. In the textbook, as we name it, we use iso. So let us name it using iso. So E, A, B, C, D, E, F, G, H, I. So I comes later and then comes M. So this will be first, ethyl I'll write first, isopropyl I'll write second, and methyl would be the third one that I would name, and then I will name the compound. So let us start. We have to start with ethyl. If there are ethyls, how many ethyls are there? There are 2 ethyls. So the diethyl D is not taken into alphabetical. You do not take D. D is only to tell you that there are 2 ethyl groups. So what is the locant for the ethyl groups? 3. So we'll write it is 3,3-diethyl. Okay, it is 3,3-diethyl, and then we'll write the isopropyl. What is the locant for the isopropyl? 4,5. So we'll write 5 isopropyl. Then you have 3,3-diethyl, 5 isopropyl, and 4 methyl. 4 methyl, and what was the word root? Octane. Do you get me? That is how we will write the name of this compound. It will be 3,3-diethyl, 5 isopropyl, 4 methyl octane. Interesting. So what were the rules that we followed? The same. We first found the longest chain. Then what did we do? We found out the lowest sum of locants. And the next step was that in alphabetical order, we wrote down the names of all the substituents and we gave the name of the compound. Next one. Let us now do this compound. Count the longest chain again. This seems to be the longest chain. If you really look, even if I turned this way, I would have only 3 carbons here, while here I see 5, it going up to 5. So obviously this seems to be the longest chain. So let me count the carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 carbon atoms. So if it is 10 carbon atoms, it means the word root will be dec. So it's a decane. I will be ending the name with decane. Now if I look here, I have 2 substituents, 2 branches. Do you see? One branch is here, and the bond from the skeleton, there is one bond here. So this is the second branch. If I change the structure of this, second here, let me expand this. This CH is attached to 2 CH3 groups. So if I put one CH3 here and one CH3 here, I just expanded it to make it clear what the group is. Now one of mine, this is one substituent, and that's the second substituent. So what are my substituents? This, as you see, as we did here, is isopropyl, right? This is a propyl, it has got 3 carbons and the second carbon is attached. This group is known as, the common name for this group is isopropyl. And if you look at this, this would be either, it would be 1-methyl propyl if you write the IUPAC name. But if we want to, just as we chose the isopropyl here, what is this group known as? This group is known as the secondary butyl group, right? When the second carbon is attached and it is branched like this, it is the secondary butyl group. Why? You would say, why do we not call it isobutyl just as we did in this case? The isobutyl group actually is where this carbon would have been attached to if this is the carbon of the chain, this carbon would have been attached to that carbon, and the next carbon would branch out into CH3 and CH3. This would be CH, this would be CH2. This would be isobutyl. If this was my group, I would have called it isobutyl. But here it is the second carbon which is attached and the methyl is coming out here. So this is secondary butyl group. So what are my substituents now? I have isopropyl, and secondary butyl, right? These are going to be my substituents. Now let us first choose the locants. Let's count from both the sides and see what are the locants that I'll get. If I count from this side, 1, 2, 3, 4, my first locant is 4 and my second locant is 5. If I count from this direction, I'll get 1, 2, 3, 4, 5, 6. You know, this will be 6 and 7. Obviously, my lowest locants are coming from this side, so I'll count from this side. So it will be 4 and 5. What is 4? On position 4th, I have the isopropyl group, and on position 5, I have the secondary butyl group. And the compound is decaying. Oh God. So if I'm naming them, no barking, no, it's all okay. Okay, so now when I'm naming it, what will I do? I'll first write, okay, choose the alphabetical order. For alphabetical order, what all am I choosing from? I'll choose I from isopropyl. I told you in the previous one, isopropyl is one word, so it is taken as, I is taken in alphabetical order. And in secondary butyls, you have a hyphen here, so this secondary is only to talk about the position of attachment. The group is butyl, so your alphabet here is butyl, B. So what comes first, B or I? B comes first. So you write the secondary butyl, that part will be written first. So the secondary butyl is on the 5th carbon, so you write 5 secondary butyl, right? And 4 isopropyl decane. That will be the name of your compound. 5 secondary butyl, 4 isopropyl decane. Come to the next one now. Again, this seems to be the longest chain. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 means nonane. The compound should be nonane. And it has only one substituent. Do you see there's only one bond here coming from the skeleton. So there's only one branch. This entire thing is one branch. This entire group. We see it has a quaternary carbon in it. But let us name. When you have such a group, then we see that this is a complex substituent. How? The substituent also has substituents or branches. It is a branch which further has branches. So this becomes your parent according to IUPAC nomenclature. This is your parent chain and these two become your substituents. Right? So this becomes 2,2, if this is the parent, this is the first carbon, then this is the second carbon. So 2,2-dimethyl propyl. The name of the entire substituent would be 2,2-dimethyl, or since I'm starting the entire name here, I'll start with a capital. 2,2-dimethyl propyl. But this entire thing is the name of the substituent. So I'll put this in a bracket. I'll put this in a bracket, and now for this entire substituent, what is the locant? What is the locant? Let's count from this side. 1, 2, 3, 4, 5. Locant is 5. 1, 2, 3, 4, 5. From both sides, the locant is 5. So I'll write 5 and put a hyphen here. It tells me on the 5th position, I have a substituent or a branch, and that branch is 2,2-dimethylpropyl. And what was my compound? It was no name. So 2,2-dimethylpropyl, no name is my compound. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So 2,2-dimethylpropyl, no name. Cloudy, peachy, no, no. It's okay. And now the last hydrocarbon here. Again, let us choose the longest chain. 1, 2, 3, 4, 5, 6, 7. Oh God. 7 is heptane. And the two substituent groups are methyl and ethyl. Right? Methyl and ethyl. So, if we count from this side, 1, 2, 3, 4, 5. 3 and 5. And if I count from this side, 1, 2, 3, 4, 5. Again, I get 3 and 5. Interesting. We are getting the same locants from both sides. So which side should we choose? Is it now okay to choose from any side? If you are getting the same numbers on both the sides, then you will choose the locant according to the alphabet too. So that you get not only the lowest locant as you're writing the name, also the lowest in alphabet. So the alphabetical order is, this is methyl group, this is ethyl group. So ethyl group comes first and methyl comes later. So this should come first and this should, so we'll count from this side. So we'll say it is 3 ethyl, right? 5 methyl, and 1, 2, 3, 4, 5, 6, 7, heptane. Right? 3 ethyl, 5 methyl, heptane will be the name of this compound. 3 ethyl, 5 methyl, heptane. Yep. So with this, I'll wind up today's video. If you found it helpful, please give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. And even if you have to play with Cloudy and Peachy because they really want me to play with them. Thank you. Bye-bye for now.